Hello, everyone, and welcome to the third episode of No Name podcast with folks from Talsec and our dear guests. As usual, let's start with just a brief round of introduction. You probably already know me. My name is Oleksandr Leushchenko. I'm a Google developer expert in Flutter and Dart and engineering manager at Tide. And today I have, as usual, again, Tomáš with me. Tomáš, want to introduce yourself?
Hi everyone, I'm Tomáš. I'm product owner Talsec, mobile security nerd.
Nice. And today we have our dear guest, Devyany, with us. Devyany, do you want to introduce yourself?
Sure. Hey, everybody. My name is Devyany. I am a senior product security engineer at Tide. Everything related to product security, mobile security, I'm the person to go forward for.
This is so true. Yep. And recently we had an interesting conversation with Devyany and we talked about Keychain, Keystore. And I know that not every mobile engineer understands what Keychain and Keystore really are. So, Devyany, maybe you can tell us what they are.
So, Keychain and Keystore are like data storage facility, which is provided by Android and iOS. They have a limited set of features, which is basically securing any sensitive credentials or tokens because in a while, data security is something which a lot of mobile engineers don't actually work on very depth. We have so many financial applications. We have so many of applications where malicious intent have been tried to be accessed. And then because of the unauthorized access, they leak a lot of tokens, they leak a lot of authentication, authorization, and then there is unauthorized access to the applications itself. So Keychain and Keystore was provided by Android and iOS so that people can utilize them to secure their tokens, credentials, user credentials, biometrics and stuff into those storage units. Now, they work a little bit different from each other, but it depends on the operating system because like Keychain is specifically for iOS and Keystore is specifically for Android. In Android world, it's a bit different because Keystore only stores keys and not the actual data. These were meant to only store keys. And once you encode or encrypt anything from those particular keys, you store the actual information into shared preferences or maybe any other secure storage. But in the case of iOS, it was something where you actually store the data. And yeah, that's pretty much it for what the gist of Keystore and Keychain is.
Okay, so they are similar, but kind of semantics of their usage is different. And for iOS, you can store like anything there. While for Android, it's mostly for keys, and that's my responsibility as Android engineer to use this key with, for example, shared preferences and store secure data there. Okay, so what's the main difference between iOS Keychain and Android Keystore? Like, I can understand that semantics is different, but let's imagine that I engineer and I don't care. And I want to store everything in Keystore because why not? Will I get any penalties from Android? Like, why should not I do that?
So basically, you shouldn't be utilizing these special storage for mass storage of data because your application will have a lot of issues regarding latency, regarding memory issues. These were generally made just for authentication and authorization purposes. That's it. If you are using it to store, I don't know, like a big UUID where you are an UUID with a couple of transaction details, your application will have more time to access such keychain or key store data and then utilize it at the back end. So your application will become very slow in this case, and it will not be the correct way of utilizing them. Also, your application will have an issue with the memory. For example, like if you're in the case of Android, your key store is specific to your application. So it containerizes it, as in one application will have its own key store, and you will manage every key in there, everything. Like if you want to encrypt any data, you will map those things in the key store and then utilize it to be added in shared preferences. But in the case of keychain, They are not specifically for our application. That's a system-wide keychain, which is provided by iOS. And when you want to utilize it, you have to provide specifics like biometrics, like if you want to utilize a pin, device pin, or device biometrics, which Apple has done very nicely now, because previously you don't actually had to have a pin or a biometric setup on your devices, but now iOS have made it as a mandatory stuff, and all the previous flags have been deprecated by iOS. So if you want to utilize your app in a way that it's faster, don't store big data into Keystore or keychains.
Whoa, I have so many questions now. And the first one, where Keychain and key stores are located? Because you mentioned that we'll have some problems with memory. Are they stored in internal or external storage on Android? Can I store key store on my SD card, for example?
No. So these are something which are already added by the devices when they are manufactured. And for example, in the case of Android, if you have a key store that is on the hardware security module called as TPP or a Strongbox, and in the case of a keychain, it is having it in secure enclave. So these are like separate hardwares created just to back these keychain and key store. There are few devices like maybe some of the Chinese devices or some of the other mobile operating system like Graphene, which might not come with these hardware security module, which is provided by Android and iOS because they were manufactured differently. So it all comes down to hardware, and these are stored in like internal hardware. So it's not even like software based, it's more of that they are backed up by these hardware, so that the access is always via biometric or always via pin code of an application.
So they are not equivalent in terms of security guarantees, Keychain and key store. No. And what about Android? Can I think that Keystore is always secure?
A very interesting topic there. Keystore and Keychain were meant to be secure, but of course, the attack paths which have been created, and we have so many nice and great researchers who have been working towards getting access to these Keychain and Keystore and making them stronger and stronger as much as possible. Though there are always somebody who will try to attack these, and there are few tools and techniques. Like if you have a rooted device, you cannot do anything about the key store. It will be accessible on a rooted device directly. Whatever the keys have been added in there, they will be easily accessible in a rooted device by an applicant. And then what they can do is they can try to understand which particular keys or which particular data in a shared preferences can decrypt that. That is a script which they can write and just have a looping going on so that they can understand which can decrypt the data and get the data back. So Keystore is not always the like fully secure, but yeah, if you have proper biometric and your phone is not stolen and not rooted, then for sure it's very secure as well. But in the case of keychain, it's a bit different because jailbreaking a device is a little more harder to perform, first of all. Secondly, because of the biometric functionality, biometrics are always stored in a secure enclave. They are not actually stored in keychain. So what happens is that whenever you want to open a keychain, you have to first go to secure enclave and then get access to the biometrics and then open a keychain. So it's a bit complicated road where people cannot never go to a secure enclave to get the biometrics back. That's why key stores are more vulnerable to attack patterns because of how they have been structured. Keychains are more protective in those cases.
Yet another reminder that you should not really root your device without a reason.
Yes.
Alrighty. Should we use Keystore and Keychain for everything that's sensitive, or maybe we have some alternatives?
We have a lot of other alternatives as well. Don't store everything because, again, the latency issue, which we spoke about before, can happen. These are specifically for tokens or certificates or private keys, right? So, if you want to have like an authentication where you want that a specific member or a user can be recognized from the device itself, then you can use Secure Enclave also. Secure Enclave Strongbox are like HSM modules, which are hardware security modules in Android and iOS. And what you can do is you can store your private key in those hardware security modules so that even though the phone is compromised, nobody can get access to those private keys. On the other hand, if there is a set of credentials or a set of token like session tokens and stuff, you can store it in a keychain or a key store so that it's easily accessible when you log in into the application. You just require a biometric to unlock the keychain or key store, get the particular token and use it to call your APIs at the backend. So not everything should be stored there again because of latency, but there are few things that you need to keep in mind when for which particular use case you will be using which particular data source.
You mentioned latency several times already. How bad it is? Are we talking about half a second latency, a minute, 5 milliseconds?
Because of the new operating systems and the new versions of the phone with so much processing power, we have a mini supercomputer in our hands, right? So it does take like milliseconds to open up a keychain or a key store. But if you want from a member's perspective, because of how fast these resources are, you don't want your application to lag on the biometric front. So you have to make sure that what you are accessing from the keychain or key store, which can be utilized by API calls rather than just utilizing it for like each and every call. For example, once you have opened the keychain or a key store for that particular biometric session, it will always remain open. So your major task is once it is open, you will just grab it and use it for each and every API call till the time the biometric expiration has happened. But in the case of, for example, if you have a condition at the back end saying, was the member authenticated or not, right? So for all those four features, you don't want it to be like coming up each and every time to open a keychain or a key store, check it, and then send it back. That's why latency is important in that case. It is for sure faster now because of how the systems are made, but still you will require, because members who also want fast applications or user also want fast applications, you require to think about where we want to store what information. If it is easily accessible, then you need to check which data source it is. If it is not, then you need to check where you can store it.
Okay, yeah, got it. That makes sense. Are there any other real-world limitations a developer should know about? For example, is there a size limit on the data that we store in keychain? Or
Yep.
maybe not?
There are limits. There are like how much MB of limits there. But now again with the new operating systems that have also been increased because you don't have to store a lot of data in these keychain and key stores again because of like how many keys will you store. It's just for encryption of the data and then you are putting it back into the place where you want to get the data from, right? So in the case of course you don't have to store a huge token, maybe multiple tokens, session tokens, because tokens expire, right? So that's why you can store tokens, you can store credentials. But if you want to store like user location information or user, like in iOS we have NS user defaults, which is basically what is the preference of the user, whether they want to choose English or maybe they want to choose Hindi or any other languages, right? And those kind of details you don't want to store it in a keychain because whenever your app is open you want to show that language as soon as they can open the application. Now to begin with, if you again access the key store or keychain in these cases, first of all, your key store will become like very big because of all these location information, preferences. Maybe you are also storing some like geolocation data, latitude, longitude, VPN details, etc., etc. That becomes hefty for a keychain, and then because you have to search which particular key you will be using or which particular, like in key store you have to check which key you will be using to decrypt the data. In keychain world you have to have the mapping where you need to check which particular data you want to address, and then take that data to be sent to your application, right? So those kind of things you don't want to perform a mapping in the keychain. And that's why when you make it bigger, the latency comes into picture. Memory is an issue, but because of the new operating system, I won't say like memory will be a big issue. The big issue for every mobile developer is latency.
Okay, got it. Any like rule of thumb recommendations what to store in Keychain and Keystore? Just authentication keys, and that's it. Or maybe there is more.
You can store like tokens, you can store authentication details, you can store the keys for encryption and decryption, you can store certificates as well. Metadata at some level. Metadata, I would again say, because when we talk about metadata, there can be 100 of metadata which you want to store. But if you want to store something which is specific to the member, that is fine, or a user, that is fine. But in the case of, if you just want to store location data, or if you just want to get the default behavior of the application, then ns default store ns user default is there. Then you want to have, for example, there are external storages, there are internal storage, there are file system storage. Let's take an example of media files. If an application wants to get access to the media files, right, at that time that will be an external storage, because all the application wants to access that media files, right? But in the case of like mapping of some of the data, which mapping of some of the data as in which particular time period, like the last device was accessed in, and all these details, you don't want to store it in a keychain or a key store. Make it specific to only deliver what from where the security is coming from. That data should be stored in keychain or a key store. But if you want to have any default behaviors, ns default user is there. Even in Android, you have internal and external storage. If you want to access media, then you can have media type storage, where you can just access the files, you can access images, you can access music and everything. So we have to plan it accordingly. For like rule of thumb from my side for every mobile engineer is, read about each and every kind of storage and understand like what your feature requires, because these operating system have done a very well job to make sure that you get all the type of storage, but which one to use for what is something which a mobile developer should be knowing about.
Got it. Okay, yep, that makes sense. Are there any tools you recommend for checking whether a mobile application is storing data securely?
Yeah, first I will recommend like a checklist before I recommend a tool. There is a checklist specifically created by OWASP. It is called as OWASP MASVS, Mobile Application Security Verification Standard. And what this standard tells you is how you can create your mobile application securely. There is a separate section for data storage in this MASVS. And what this will tell you is how you can store, what needs to be stored where. It can also tell you where the encryption, which particular encryption algorithm to use while storing the data. And if you want to access something externally, how you can do it securely. So this is a very good checklist created by a lot of researchers in the wild, where they actually think about like how to proceed with the OWASP MASVS. On the other hand, there is a tool called as Mob SF that is also a tool created by a bunch of good researchers, where they will try to upload an APK or upload an IPA file to understand where the data is stored and give you a score on the basis of whether it's securely maintained or not. Those two things are basically a go-to thing for any mobile developer to just go and check whether they are building a secure storage application or not.
Okay, Mob SF, you call
Yeah.
it?
SF.
Cool. I have one, my probably last question, but before that, Tomasz, maybe you have any questions from your side?
Yeah, sure. I wanted to ask you, Devyany, like, how would you handle like, practically, what should developers do if their, like, applications they control are installed on devices where this hardware-backed module isn't installed? Because I've heard 5% of devices doesn't come with hardware-backed module, or maybe it's some kind of emulator or some kind of device. So how to handle such a difficult situation?
So to handle such difficult situation, because they are not having any hardware based storage, what they can do is go towards a software based storage, and there are a bunch of libraries to do that as well. It's not the best approach, I would say. Like, we build the application for the popular operating systems because they have all the things inbuilt, and they have thought about security in more depth than the new operating systems or the 5% one which you mentioned. But if there is no way that we have to develop for those as well, then a lot of people rely on the software based hardware security modules as well. There is Bouncy Castle is one of the libraries which you can use to perform this cryptographic operation. What actually the similar thing, and they replicate the similar thing what Android and iOS is doing. Though it is software based, so you never know if there is any zero-day attack on the packages or anything happens, then these can be vulnerable, the attack vectors in itself. That is why it is much better to use hardware based one rather than the software ones. But yeah, there can be a fallback operation to use these libraries.
Thank you.
Thank you.
Great. Thanks for the question. And Devyany, what's one key takeaway you want every mobile engineer to remember about secure storage?
My major key takeaway for every mobile engineer to understand what type of data can be stored where, and or maybe let's jump a little bit back to first understand what type of storages are there for each and every device. That will bring up immense amount of clarity for every mobile developer to when because they know what features they are developing, they know what data they want to store. The only thing is where to store it is a big question for them. So if we read about what type of storages are there and what they can store, what is secure and not, I think that is something which every developer should follow first, and then they can proceed towards building the feature, because that is something which they are more talented in.
Yeah, got it. So I assume that we all should read MASVS and understand what's there in MASVS, right?
Yep.
Cool. Thank you so much for this conversation. It was really a pleasure having you here. And I hope that's not the last time when we see you here in in this podcast.
Yeah. Thank you
So
so much.
thank you so much.
Thank you so much for
Cool.
inviting me.